Hello all and welcome to Bitesize Insight. This is your fifth lecture on playlist of precalculus. In previous couple of videos, we have discussed equations. In this video, I want to discuss inequalities, where things are necessary, not equal. So let's get started. Let's begin with taking a real number line. So let's take a number line and let's take 2 points on it. Let's say A and B. So as you can see, A appears left of B. So if A appears left of B, then we say in symbolic notations that A is less than B, where this is the sign of less than. Okay, we can also rewrite this using a greater than symbol. Yeah, and how can we do this? We can also say that B is greater than A, where this is a greater than symbol. Okay, there are two other symbols, that is A is less than equal to B, which implies either A is less than B or A is equal to B. In other words, we can say that A is left of B. A is left of B. Then there is one more symbol left, that is A is greater than equal to B, which further implies either A is greater than B or A is equal to B. Or in other words, we can say B is right of A. Okay, for understanding this more deeply, let's take a more simpler example that will clear everything. Suppose we have a number line again, and there are various random points on the number line. So that is, let's suppose -20, -15, 0 and 5. So if we have to write it in terms of symbols like less than or greater than, we can say -20 is less than -15 is less than 0 is less than 5, which we can also say that -20 is less than 5. Even though in terms of magnitude -20 is greater than 5, but we are not dealing here in terms of magnitude, we are also considering the position of it on number line. So we take -20 as less than 5. The term magnitude, we will discuss it in our later videos, but for now we have got these symbols less than, greater than, less than or equals, and greater than or equals. Let's explore some relationships between numbers that use some of these symbols. Let's revisit the example 2x plus 1 is equal to 7 we have discussed in previous videos. But instead of equals, let's turn it into an inequality and try to solve that inequality. So let's take that example. Okay, first let me change my sheet. So, as we have previously discussed the example of 2x plus 1 is equal to 7, but rather than equal, let's take the less than symbol. So suppose 2x plus 1 is less than 7. So as you know, subtracting 1 from both sides, we will get 2x plus 1 minus 1 less than 7 minus 1, which will further be equal to 2x is less than 6. Implies x is less than 6 by 2, implies x is less than 3. Let's do a little bit more elaborate, where x appears more than once. The idea is same. We have to isolate x and solve. So take the example of 1 minus x is less than 3x plus 6. So adding x on both sides, we will get 1 is less than 4x plus 6. Subtracting 6 on both sides, we will get -5 is less than 4x. Or in other words, we can say that 4x is greater than -5, or x is greater than -5 by 4. Now, we can also approach this same problem by a different technique or a different method. Let's say I have the same expression, 1 minus x is less than 3x plus 6. Now instead of doing this all algebraically again, I can do this what can I do this is I can multiply both sides by -1. I'm going to take negative of both sides, and when you do that, the inequality flips over. The reason for that is when you multiply by a negative number, the relative left and right positions of the number on the number line get inverted. It's like looking in a mirror. Left become right and right becomes left. Anyway, the rule is if you multiply by a negative number, then the inequality flips over. So less than become greater than becomes less than, and so on. So in this case, if I multiply negative sign on both sides, it will become this. Okay, my bad. The equality flips over, implies this will become this, implies our above expression will become this. According to rule, when we multiply -1, the inequality flips over. So here it was less than, now it will be greater than. So simplifying it, we will get x minus 1 is greater than minus 3x plus, minus 3x minus 6. Now, adding 3x on both sides, we will get x minus 1 plus 3x is greater than equal to minus 3x minus 6 plus 3x, which further simplifies to 4x minus 1 is greater than, we will getting here minus 6. Now, if we simplify it more, we can say that 4x is greater than minus 5, which further simplifies us to x is greater than minus 5 by 4. So we have approached the same problem of inequality by two different methods and discussed a very important rule in it. So most of the manipulations we did, we maintained the inequality, isolated x and solved for the inequality. Just be careful when you multiply a negative number, you change the inequality. I think this is enough for today's video, and it's time to sign off.